Hey, my friends, it's the NOLA Mathman back again to go over some math concepts and attack your math fears. Unlike Superman, I cannot leap over tall buildings in a single bound, or I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
so let's get started with today's lesson. After this lesson, students will be able to solve linear systems of inequality by graphing. The concept we're looking at in this chapter is linear systems, and the skill we're going to do today is solving linear systems of inequalities by the process of graphing. Let's get started. So today we're looking at solving linear systems of inequalities by graphing. Our first problem said solve each system of inequality by graphing. So we have two linear inequalities to deal with, x greater than or equal to x greater than negative 2. And we have 2y greater than or equal to 3x plus 6. So again, since the first linear inequality is a constant, that means we will create a vertical line, as you can see here on the screen. And so we will have a vertical line at x equals negative 2. So because it does not include the equal sign, as our little chart here says on the right of the problem, we will have a dashed line at negative 2. Since it is greater than, as the chart indicates, that means that we will shade above. Above in the case means to the positive direction, which is to the right. And so since we drew our line as a red dashed line, we're going to shade using the color red as we are doing now. So we have a lot of region to shade, and so that's what we're doing. And there we go. It takes a minute to shade through the region. Now, as you can see to the right, we have a chart that illustrates the 4 different types of linear inequalities that we can have and what various types of lines are produced and do we shade above or below. And so using this thing will help you a great deal when you're trying to graph inequalities. So we graphed x greater than negative 2. Again, a dashed line at negative 2, 2 units to the left of 0, and we shade to the right since it's greater than, and that denotes we're going in the positive direction, they're increasing. So now we go to our next equation, 2y greater than or equal to 3x plus 6. Again, we write our general form of slope-intercept form to pull out m and b. We don't do that until we solve for y. So since we have a coefficient of 2 times y, we have to divide every term by 2, which we do. And so the NOLA Mathman comes with y greater than or equal to 3/2 x plus 3. At this point, we pull out m and b. The NOLA Mathman has concluded that the slope is 3 over 2. We want to set that to rise over run so that we can use it to graph. Our y-intercept is b equals 3, so that means the graph will cross the y-axis at 3. So we are now in a position we can graph. Now, is this going to produce a dashed or solid line? Well, because we have the equal sign, greater than or equal, we know that we will have a solid line. So we start the process of creating our line by graphing the y-intercept first. We go 3 units up from the origin and we put a point at 3. To indicate the rise over run, since we don't have 3 units to go up, we go down and to the left. So we go down 3 spaces and we go left and we create another point at negative 2, 0. And then we go down 3 spaces and to the left again to create another point. So now we have 3 points. Since we know it's a solid line, we're going to draw a solid line connecting those 3 points, and that will be our inequality. Well, that'll be our equality, our equation, but then we have to shade to determine the inequality. So at this point, we're going to connect those points using a solid line, because again, we include the equal sign. And that should pop up on the screen any second now. So there we go. There we go. So there's our line. We want to put arrows at the end of the lines because we know that these lines go on indefinitely in both directions forever. So we always have to put arrows at the end of our lines in both directions. Now, since it's greater than or equal, do we shade above or do we shade below? Let's see what we do. Well, it says greater than, so we know we will have to shade below. So since we're using the blue color to graph this line, we want to shade using blue coloring also. So that should show up in a sec. There we go. And so we shade right there. So what is our solution when we shade the two equations and represent the two linear inequalities? What will our solution be? What do you think it'll be? Now, as you can see, there's a lot of regions. You have some regions that's in red. We have some regions that are shaded in blue. So what will a solution of the two inequalities be? Well, I would assume it would be the mix of the blue and red regions. And so that's what we will indicate. And as you can see here, as we're shading our blue, it is indicated in that little triangular space to the middle of the graph. That looks like that's where the two regions will intersect. And that will be what we call our solution, which we will indicate with this arrow here, yes, and we will write solution. And so this will be our solution to the linear inequalities x greater than -2 and 2y greater than or equal to 3x plus 6. So we have completed our first problem. How's that? So that's good. Again, we have a phrase in New Orleans, don't talk about it, be about it. So we're being about it, some of these problems here, and being as thorough as possible. So that's our first problem. Now we're going to go on to the second problem here that we will do in this concept of solving systems of inequalities by graphing. So we'll pull up our next problem in a second here. Here we go. Looks like it went in and out. So, there we go. Instead of doing number 3, we're going to go on to number 4. There we go. So our next system of inequalities we have is x plus y greater than -2 and 3x minus y greater than or equal to -2. So like we did in the first problem, we do each equation at a time, we graph. So the first equation we have here is x plus y greater than -2. So we write our general form, y equals mx plus b. We solve for y by subtracting x from both sides. Once we do that, we will end up with y greater than -x plus minus 2, because our 2 is negative. We're now able to pull out our slope, which is -1/1. We want to set that equal to rise over run, because that's the formula we use to generate points for our slope. And our y-intercept, b, is -2. So at this point, we're now ready to graph our first equation. Again, will we have a dashed or solid line? Now again, I go to the chart. This time we circle the particular form that we will be using this problem, which means we will produce a dashed line and we will shade above that boundary line. So we know we'll have a dashed line because it doesn't include the equal sign. So first thing we do is we plot our y-intercept at -2. We go down one space and to the right and we put another point. We go down one space and to the right and create another point. And then create some points to the left of our y-axis. We go up and to the left. And so by the time we come up with a bunch of points, so we can be as accurate as possible, at that boundary line we create a dashed line because it doesn't include the equal sign. We want to put arrows at the end of the lines to indicate they will go on forever. And since we say it shades above, since we drew the boundary line using green, we will use green coloring to shade our region above the boundary line as we are doing now. So the NOLA MATHMAN is shading the region. He's a little slow in his shading. He's more of a math man than an artist, so we have to be a little patient with the NOLA Mathman here as he attempts to shade. So he's getting it done slowly but surely. Sort of like the tortoise and the hare story. NOLA Mathman takes his time, so he tries to be as thorough as possible. So we've now graphed our first inequality in green, and so now we want to graph 3x minus y greater than or equal to -2. And once we shade that region, the intersection of the two regions will be our solution, like we did in the first problem. So at this point, we're going to erase our work from the first inequality. And we're going to write down the second inequality and put that in slope-intercept form. Does everyone know at this point what the slope-intercept form is? Do we know? Sure we know. It's y equals mx plus b. So that's what you will see popping up above the problem. So we have here 3x minus y greater than or equal to -2. We'll put our slope-intercept form above the problem. To solve for y, we must first subtract 3x from both sides of the inequality. We bring down our -y greater than or equal to -3x minus 2. To get positive y, we divide all three terms by -1. We end up with y. Now, when you divide by a negative, as you can see here, we switch the inequality around. That's called the golden rule of inequality. Anytime you multiply or divide by a negative, you must switch the inequality around. So at this point, we will pull out m and b. The slope will be 3 over 1, which is, we want to write it in rise over run form. That's why you rise a fraction. And our y-intercept is 2. So we circle the particular inequality that matches this problem, which is the y greater than or equal. So we will produce a solid line, and we will shade below the boundary line. So at this point, we graph our y-intercept, which is at 2. To illustrate the rise over run, we go up 3 units and to the right 1. To get some points to the left of the y-axis, instead of going up and to the right, we go down 3 units and to the left. And so that allows us to generate 2 more points, and now we connect those 4 points to create our boundary line, which again, since it includes the equal sign, it's a solid line. We use yellow to illustrate this inequality. We put arrows at the end of the lines as we've instructed, as NOLA Mathman wants us to do. And since we're shading below, we shade the region below in yellow. And as you can see here, we start to see an intersection of the regions of green and yellow, and that will be our solution, that intersected region, which will be at the right side of the two lines, as you can see there. As you know, the NOLA Mathman is very thorough, so it takes him a while to shade. He wants to be very thorough and detailed. And so once we do this, we will use our arrow to indicate the solution region for those two inequalities, which will show up in a second. So what region do you think it is? And we have 4 regions formed. We have one to the left, to the top, to the bottom, to the right. Which region do you think will be our solution? Oh, look, it's the one to the right. And so we use the arrow to indicate that area. That's our solution region, and we will write the word solution to indicate that that is the region. All right, so we're done with 2 problems we solved using our system of inequalities by graphing. Very good. So, like we're on our way here. So I hope everybody's understanding. As you know, the more of these we do, the more comfortable you will get. The key is obviously knowing your little inequality rules that we put here on the right. It's very important to know whether it's a dashed or solid line, whether you shade above or below. And another thing that's very useful when graphing linear systems of inequalities, you need to know your slope-intercept form. And be able to put equations in that form. So that's very important for us to master this concept. So now we're going to do another problem. This problem looks a little different because we have a absolute value here, which is different here. We don't just have two linear inequalities. We actually have an absolute value inequality in our first system there. So the problem we have here reads the absolute value y less than or equal to 1. What kind of line do you think that'll produce? And then we have y less than x minus 1. What kind of line and shading do you think that will produce? Well, we're about to see. The first thing we do, we want to start with one inequality at a time. We'll start with our absolute value inequality. Absolute value y is less than or equal to 1. Now again, when you have absolute value inequality, you break that up into two inequalities because you have the absolute value y is equal to the absolute value negative y. So in order to solve these, we get rid of absolute value, we create two inequalities, y less than or equal to 1 and negative y less than or equal to 1. So obviously y less than or equal to 1 is solved for. For negative y less than or equal to 1, we want to divide both sides by negative 1 to make the inequality y. Y ends up being greater than or equal to negative 1 because we have to switch the inequality around as we learned in the last problem. That's the golden rule inequality. So we have to graph both equations and get their region, and that will be our solution. So for y less than or equal to 1, that is a solid line, horizontal line at 1, as you can see drawn. And then for y greater than or equal to negative 1, we draw a boundary line at negative 1. Since it's greater than, we go up from that one. Since y less than or equal to 1 is less than, we go below. And so that creates a region in between the two horizontal lines, and that is our solution for that. And so you can see that shaded in red, shade. So at this point, we have graphed our first inequality. The absolute value of y is less than or equal to 1. We erase our work, and we will now graph the second one. So next we have y less than x minus 1. Using our slope-intercept form, we will pull out our slope and y-intercept like we normally do. M is equal to 1, so that will be 1 over 1. We want to write that in fraction form and put y's over run. Our y-intercept is negative 1, so that means it will cross the y-axis at negative 1, this line. And so that allows us to circle the second thing that says we will have a dashed line and we will shade below. So at this point, we start to graph our points so that we can create this dashed line. And so since our y-intercept is negative 1, we put a point at negative 1 on the y-axis. In order to get our next points, we go up 1 and to the right 1. And to create some points to the left of the y-axis, we go down 1 and to the left 1. And so we get a bunch of different points so we can get as accurate a line as possible. Since it's a dashed line, we will draw a dashed line through these points, as you can see. It's popping up here. And we want to put arrows to indicate that this goes on, this boundary line goes on forever. And since we shade below, we will shade below in the blue shading. And as you can see now, you can see the intersection between the area that is shaded in red, and you can see an intersection between the area that's shaded in blue. And again, the NOLA Mathman takes a while to shade. He likes to be very thorough. You don't want to make mistakes in shading. And so you got to be very careful when you shade your region. And as you can see, we see an intersected region in between the two red lines to the bottom of the, so it's like a little, I don't know, a little trapezoidal region that is formed of the blue and the red intersection. Now, we want, again, like we normally did in the first two problems, we want to use an arrow to indicate our solution region as it pops up here. That's that region right there. And I'm sure that's what you got when you did it, because you know this is our third problem. So at this point, I'm sure we're getting very comfortable with determining the region. So we're done with problem number 5. Very good job, class. So we're on our way here. So we're done with number 5. So let's see what we will do next. So we get rid of our little regional stuff there. Looks like we get our little table out the way. We might have a new set of problems we're dealing with different directions. So if we're moving our little table, that means we might be doing a different type of problem for this next one. So let's see what the NOLA man does next. Let's see what comes up next. So next, I'm sure the problem will pop up. And there we go. So now we're going to do a problem where we find the coordinates of the vertices of the triangle formed from each system of inequalities. So we're going to graph a system of inequalities. We're going to create a triangle from that. And from that, you and me will determine the vertices that are the solutions. So our first problem we want to do, we want to expand it so everybody can see it. We have here y greater than or equal to 2x minus 2. The next inequality is 2x plus 3y greater than or equal to 6. And then our last inequality will be y less than 4. And so we create a little grid here. We want to create a little xy coordinate plane to graph our work. So like we did in the last set of problems, we'll start with our first inequality. Y greater than or equal to 2x minus 2. We put our slope-intercept form above so we can pull out our slope and y-intercept. In this problem, slope is equal to 2, so we write as 2 over 1, so we can put in rise over run form. Our y-intercept is negative 2. So at that point, we can graph what we're doing here. Look like to know, oh, we want to put our region here, our little table, so we know how to graph our linear inequality. So in this problem, we have greater than or equal. So we circle that part of our chart, which means we will produce a solid line and we will shade below. So we graph a point at negative 2 on the y-axis. We go up 2 spaces to the right one, and we do it again, and we create another 2 points. And to create a point to the left, we go down 2 and to the left. We know it's a solid line, which we draw. We want to put arrows at the end of the lines to indicate they go on forever, which should pop up in a second. And we are now done with our first linear inequality. So at this point, we want to shade. Since we shade above, since it's greater than, we will use our red marker to shade that region above the boundary line. And again, the NOLA Mathman wants to be very thorough, so he's very detailed in shading so that he doesn't cross his boundary line or make any mistakes. And so we're shading the region here, as you are to do in your little graph paper that you're doing. So while we're doing that, we're getting ready to do our next linear inequality, which will be 2x plus 3y greater than or equal to 6. So we're about to do that. Looks like the shading is about done. Looks like there's a little part below that the NOLA Mathman didn't quite shade, but even the NOLA Mathman makes mistakes every blue moon, probably like once every 10 years. So it looks like he didn't quite shade it as good as he could, but it's okay. So now we're going to graph our next inequality, which is 2x plus 3y greater than or equal to 6. We want to put our slope-intercept form above it so we know what to do. Now this problem is not solved for y, so we have to solve for y by subtracting x from both sides to get rid of the 2x. Use our inverse operation. The inverse of positive is negative. We will bring down the 3y, and that will be greater than or equal to negative 2x plus 6. At this point, we must divide every term by 3 to get rid of the 3 that's being multiplied to y. That will give us an answer of y greater than or equal to negative 2/3 x plus 2. So we can now pull out our slope, which is negative 2/3. We write that as rise over run. Pull out our y-intercept, which is 2, which means that 2 on the y-axis, we will put our point. We get our first point from the y-intercept when you graph linear inequalities. And then we account for our rise over run, which means we will go down 2 spaces and to the right 3. As you can see, that point pops up. Now, since we can't do it again, we want to go up 2 spaces and to the left so we can create a point to the left of the y-axis. Now, what kind of line do you think we're going to produce? Well, obviously, since it includes the equal sign, we produce a solid line. So we draw that connecting the 3 points. We want to put arrows at the end of the points indicating that the boundary lines go indefinitely in both directions. Now, how will we shade? Well, since we circled the one that's greater than or equal, we know we must shade above since it's greater than. And so we will shade that in blue. And as you can see, you can start to see an intersection between the red and the blue regions. But we still have another inequality to graph before we figure out our vertices. So after we shade this, we will graph our last inequality, which is y greater than, I'm sorry, I said it wrong, y less than 4. So that's what we're about to graph right now. So we'll probably use a different color. We've used red and blue, so we'll probably use, I don't know, which color do y'all want to use here? I don't know, green maybe, maybe yellow. I don't know, let's go with green. So we write y less than 4. Now since y is equal to a constant, we know this produces a horizontal line, which will be written here in our notes. And so at 4 units up from the origin, we will draw a horizontal line. Now since it does not include the equal sign, we shade the one that says dash line shade below. So we know we will produce a dashed horizontal line at y equals 4. And so that's what's being produced there. At this point, we will shade below. And whatever regions are the green, blue, and red, that is going to make up what our solution is, whatever that triangle is. And at this point, you can see that triangle being formed there right below the horizontal line. And you can see the vertices. You can see the 3 points that make up the vertices of that triangle. So we have to indicate those points to be finished with the problem. We have to plot those points, and then we have to write down the coordinates that represent those 3 points. And that's what we're about to do. So as you can see, using our black marker and point, we get these 3 points. And so now we're going to determine what our coordinates are for those 3 points. Now the easiest points are the ones that are on the horizontal line at y equals 4. Those are the 2 easiest coordinates to get because they're not in the middle. They're both going to be integer values for x and y. The other one looks a little more challenging. So the coordinates for the 3 points that we have formed in our triangle are the following. Which one do you think the first coordinate is? Looks like the NOLA Mathman has gotten one to be 3, 4. And then another one looks like it will be negative 3, 4. That's 2 of them. I can see those right away. It looks like we have 3, 4 and negative 3, 4. As you can see, those are the ones that will appear first. Negative 3, 4 and 3, 4. Now the other one's a little more tricky because the x coordinate is an integer, and it looks like it's like 1.5, which is 3 halves. And then you go 1 unit up. So that's the last point. And we have now solved our problem. The coordinates of the vertices of the triangle formed are -3, 4, 3, 4, and 3/2, 1. And so we have finished the problem. Excellent job. And looks like we're done with our section. So we have finished the section titled Solving System of Inequalities by Graphing. We've done a really good job, and again, the NOLA Mathman has come to save the day and solve this concept. And so until we meet again, the NOLA Mathman is signing off. Have a great day and look forward to our next math adventure with the NOLA Man. Bye-bye.